Okay, hi. My name is Sivanina. I live in Norway and I have a master's degree in marine biology. I work as a department engineer. I'm a lot in the lab, and I'm working between the students and the scientific staff at our university in the marine biology. Where I belong to the NTNU, the Norwegian University of Science and Technology, and I work at the Department of Biology and in the section Marine Biology. So I work a lot in the lab. I have a lot of education, and I also I have the whole responsibility of a big lab, and I educate students in the lab how to do scientific, how to measure stuff, different things. So yeah, I'm sure you have a lot of questions.
Yeah. Okay, so we first wanted to ask you about your background. What got you into marine biology, and did you always want to do it as a child?
No, I actually started studying medicine in Switzerland, and then it's very tough because you have 2 chances to take the exam, and if you fail twice, you're nationally excluded from the whole, nationally excluded from this subject you're taking. So that happened to me. I could have fought and I could have proceeded, but then at the time I was done with medicine. And before I was 23 years old, I had to live 1 year in Norway to keep my Norwegian citizenship. And I did fall in love with a Norwegian boy. And I'm now married to him and we have 2 kids. So when I had to decide to not proceed my medicine career, I figured out that I would go to Norway. I told my parents that I would go to Norway and study marine biology, because you can't do that in Switzerland, right? So then I went to Trondheim because he lived here, and I started with normal, basic biology. So I did a bachelor's in biology. And then at the time, I was also interested in physiology, cell and molecular biology, a lot of things that everything you actually decide, what you go into is interesting, right? And then when I had to decide what master to do, I actually ended up with marine biology. And I'm really, really glad that I did it, because there's so many different things you can also do in marine biology, right? You have the tiny, tiny cells you can't see even in the water, and then you have the big whales. So there are a lot of different things. So that was my short version of why I became a marine biologist.
Interesting.
Mm-hmm.
So we saw on your profile something about how you were doing a PhD. Are you still pursuing that?
Yes, after my master's, I worked as a department engineer for 6.5 years. And then the professor that funded me, his funding went out, so they had to let me go. And then I was fortunate enough to get a PhD after half a year, and I started. And I proceeded for 3.5 years, and then my predecessor, she retired. And I applied for a job because I knew that I would like it. And my professor that was my boss for my PhD, he said that I should apply for a permanent position at the university, because it's very hard to get permanent positions. And then I was very sad, I had to let go of my PhD in a way, but I got a permanent position at the Department of Biology. And then my boss said that for my personal development, I can proceed my PhD. So I'm still working on it. But with a job and 2 kids, it's quite hard to finish. But I gave myself now until December 25 to finish. So I'm working hard to still, I have the writing, some of the data processing and the writing left. But it should be should be doable. So I'm still working on it. Yeah.
Do you feel like it's worth it?
Yeah, I think it's worth it. I mean, it's like, if you're really, really interested, it's like another education. You can really dive into a subject that interests you, and you can do your own experiments, and you're like, it's your project. So it's stressful, but it's very rewarding, and you get to meet a lot of other scientists, and you go to conferences and you present your work and you get inputs. It's really, really nice.
So we wanted to ask you about your career, and what did your day-to-day life look like? What do you work on day to day?
I have like 3 major, like, how do I say it? My main task is like, I have 3 major instruments that I'm in charge of. So one does like a lot of gives you a lot of results on nutrients, like what it's like the fertilizers in the water. It's nitrate and phosphate that drives all the micro phytoplankton and then the zooplankton, like all this web. So it's very interesting to know, if you start an experiment, what are your starting values, and then you do an experiment and you end up with other values, and then you know how much did they even take up or how much did they release. So it's like, or you get samples from around Antarctica or Arctica, and then you like change like the depth, and you figure out how much is in the upper layer, how much is in the deep water, and then it gives you an idea about the community or what nutrients are available. So this is like one major part that I do. And then also have like this carbon and nitrogen analyzer that can tell you something about the small particles, the small phytoplankton, the zooplankton, like the small krill. How much is it in the liter of water if you filter it? So it also tells you something about the picture.
How long do those usually take to analyze?
How long this analysis take?
Yeah.
I can, like, for the nutrients, I can do 160 in a working day, 7.5 hours. For the CN, it takes 8 or 9 minutes per sample to burn, because they burn by 900 degrees. It's carbon and nitrogen that you measure. And then for the third, like, major instrument, I do have, it's like for pigments. For like most common in carrots is beta carotene, right? You know, and like all the phytoplanktons and the corals, they have like the fingerprint. They have like different like of this pigments, yeah. So if you get a water sample and you filter it, then you can run it through this instrument, and then you get all these peaks, and then you can say, maybe we have like this phytoplankton and another phytoplankton, or there is a lot of like a third phytoplankton in it. So it's like a fingerprint for the phytoplanktons. And these samples take 45 minutes to run.
Interesting.
Siv, if I could actually ask, to help us connect the dots between what you do on a day-to-day basis to what is the impact of the work that marine biologists do?
The impact. There are a lot of a lot of people at our department work on fish farming and fish welfare, because Norway is a huge producer of farmed salmon. So it's very important to have the overview of how much they release, how much, like, there is different scientists that look into the various aspects of this fish farming. And then we have also a large group that works closely together with the marine technique, with like remote sensing, like all this autonomous vehicle that they send out and measure parameters of like variables in the water column to check if everything is healthy, if there is too much of any like of something, how it looks, and just take measurements and check for the global warming, or they're looking into what communities live under the ice in the polar night. And they all thought always that there is no life, or there's nothing happening in the polar night. If you can't see the sun anymore, right? If you go below, like above the polar circle in the winter. But now they figure out there is a lot of light. So it's gathering information and checking that the oceans stays as healthy as possible. And of course, like we have also a huge group that looks into microplastics. So I think like you have like it's like medicine, right? So you have like all these specialists, because you can look at the tiniest things. I mean, if you swallow 1 liter of seawater, you get, I don't know, 1 million of bacteria into your mouth, and you get like, I don't know, 100, like a lot of thousands of or more, like viruses and bacteria, and then you all the like the microplankton that you can't see. You have to use the microscope. So if you like 1 liter of seawater contains a lot of things you can't see, and you need someone that looks into that one, and then you need also all the biologists that look into whales and fishes and everything you can see. So it's super diverse.
Effects have global warming had on marine life?
Some, like look, you get another. You know about the food web, right? Like you have like all these tiny things that get eaten by others, and then like everything is connected. So when, at least in Norway, when you think about global warming, is that like most of the fishes, they go more north, and you get new species in that can overtake like a lot of the habitats from the others. So it's a shift. What we see here, that it's like shifting from, like the species move further north, and then maybe it's not super good for them to reproduce in this temperature, so the numbers decline. But then another species from the south takes a little over, but there's not optimal either, so maybe suddenly you have less fish, or other interactions in the web, and you get all these blooms, like micro phytoplankton blooms, that can be harmful for the fisheries, like the aquaculture salmon. So it's very important to like keep track of all the changes.
Yeah.
What's your favorite marine species?
My favorite marine species. That's very difficult. I looked into this like tiny krill. It's called the red krill. It's about 5 millimeters. So I worked a lot with them, and it's like a food for. It's like the insect of the ocean, part of, like sort of, because they're all different types. So I looked at this, and I like this like, tiny small bugs that swim around with like this huge antenna, and they're quite cute, like orange. And then they go up, and you can, like in spring, there is a huge layer, and they reproduce, and then the rest of the year they are like between 100 and, I don't know, 300 meters. And they're also very fond of the cold water corals that we have a lot of in Norway.
How do you think your career will evolve, and what excites you most about it?
I really would. I'm very happy where I am now. I would like to finish my PhD, and I would like to be more involved in teaching, because that I think is the most rewarding thing I can do, to educate new people and learn them skills in the lab and show them how to do things. And I don't know, I'm really happy at the university at the moment. I have a lot of like administrative tasks as well. But it's possible that I will change. I'm not the scientist. I'm not the I don't pursue the scientific career. Writing a PhD is fine, but if you go for a professorship, someone told me once that you educate yourself as an author, because you have to write applications to get money, and then you have to write results. So if you like writing, then that's your career to go. But I'm more the practical. I like the practical approach. So that's why I'm pretty happy in the lab and be my own boss in the lab.
So what exactly do you allow your students to do?
Sorry, I don't have to repeat your questions.
What exactly do you allow your students to do?
What I do allow my students to do, I usually I'm in the beginning when they start these master students, they have 2 years. So when they plan their experiments, I'm usually in as a consultant and talk to them what is wise to do, how to set up the experiment together with the professor, so they get really good results. And then when they can come back with all the samples they need to do, they have to process everything by themselves, and then we run the instruments together. So there are a lot of like things that I show them how to do, like how to filter water, how to pack the samples, how to treat them before you have to put them in the instrument. And then some instruments they can run themselves. And others instrument, I will prepare a lot of things, and then they will just place the samples, and then we'll look at the results together, because they are so complicated to run.
What do you think your students like most about it?
I think what they really like is usually I have 1 or 2 in the lab, so we're working very closely together. And what they told me, it was like this one-to-one teaching. I'm getting more like I'm not a teacher. I'm more like a friend, or like someone that like chats, and then they learn a lot, and they can ask all the questions they wonder, and I also help them to interpret the results afterwards. And if they have questions when they're writing, they come back to me. So they really appreciate that I use the time and help them on their way to their masters.
How do you engage your students and keep them like interested?
I'm quite fortunate because I get master students, and then they already have chosen their specialty. And when you do like in their master's period, they usually do their experiment by themselves or together with a PhD. So you're quite committed. And then it's not really hard to keep the motivation with the students, because they're already motivated to get results for their work, right? And then they know that they have to write afterwards. So I leave a lot of, like, they get a lot of responsibility because they're their results, right? So it's I don't feel that I have to motivate them a lot, actually.
Okay. What is the hardest part of your job?
The hardest part is that I have not enough time to do everything I want to do. No, I have like a lot of, the hardest part is that I get a lot of questions, that it's very nice. And I also tell the people that I can ask, but sometimes I get disturbed too much. And if I'm in the lab and I have to like put all these samples on and someone disturbs me, it's very easy to lose track of what sample you're on. and try to have my system. And then if in the end I find out I skipped one and it doesn't add up, then I have to pour out everything and then restart. And then I will be delayed in the start in the analysis, and then I have to go back in the evening to turn off the instrument. So actually it's the time aspect that is the most difficult. And sometimes it's difficult to figure out what I have to prioritize first, because I have no one that tells me, now you have to do that, now you have to do that. I have to decide myself what is most important. And that's not always easy. But it's also very nice to not have someone micromanaging you.
Yeah.
And that's why I like my job that much, I guess.
Are there any current problems regarding algae?
Algae? Yes, I mean, you have a lot of algae that produces toxin. Toxic for us, like humans, are toxic. And have you eaten blue mussels ever?
No.
No. Okay. Because like you have all these filter feeders. Mussels are filter feeders. So if you get a lot of like algae that produce toxic stuff that is toxic for humans, and then you would eat these mussels, you can actually get really ill. So in Norway, there are like 3 places along the coast, and they do measure like the algae in the blue mussels twice a week. And then they will get out an alert, like in this area, you can't eat the mussels or the shellfish. And then in another, like 500 kilometers further north, it's fine. So that has a quite huge impact, and this can suddenly appear. And last year, there were a lot of algae that are toxic to fish. So they actually killed a lot of fish that were like for the salmons in the fish pens in the sea. So you get and then there are also like freshwater. Probably you know or have heard about freshwater cyanobacteria, so they're very toxic to dogs. So if you let the dog swim in a lake that has these cyanobacteria, they can potentially die as well. So it's very important to know what algae you actually dealing with. But it's like this is microalgae, and then you have like all the macroalgae that can or can travel with boats and then get into a new area and overtake another place, right? Like another space, and then like the ones that have been there, they will disappear. So it's like you see the algae. For me, algae is microalgae you can't see, and then you have the macroalgae that are below the tidal zone, so you hardly see unless you dive. And then you have all the algae like that are in the tidal zone and above the tidal zone. So it's like macro. So yeah.
What was the hardest part of earning your master's degree?
The hardest part, there are, as you know, there are subjects that interest you more than other subjects in school, right?
Yes.
So yeah. So for me, it was the hardest part in my master's was to get through the subjects that didn't interest me that much, but they're equally important. So then I just needed to make more effort. And I have the tendency to choose things that are like not the easiest way. So I had a professor that gave me a task that he said, okay, we don't know what it's gonna be, but you have to try. And he was, I haven't had, in the beginning I had not much contact with him, but he was very helpful in the end with the writing process. So it was also like, I don't know how the master's is at your university or how it's gonna be, but we have like 2 years with subjects and then a bigger project, and we have to write the huge report in the end. So getting through the less interesting subjects that I had to take was the major challenge.
Yeah. How did you stick through these struggles?
I just knew that I had to, I mean, if you have an exam and you know you need, if you want to maybe do a PhD or later, you know that you have to put in the effort. So it was, I just had to not, just had to put in the effort. I know that it's like, I had to be strict by myself. Yeah.
What part of your job are you most proud of?
I'm most proud of when a couple of years back, I had 2 students in my lab, and we spent a lot of time together analyzing all the samples, and I had to run like a lot of samples twice, maybe 3 times, to get the valid results. And both of them they got straight A's in their master's project. And then their professor came back to me and said, if it wouldn't have been for me and these good results, their project or like their final paper wouldn't be that good. So that makes me really, really proud. That's a really nice, that's really nice to hear back that they are happy, and the professor is happy, and then they get good jobs afterwards.
What major impact do you think your job had on you?
I do a lot of I'm just how do you put it? It's like I feel that I'm like a little piece in a bigger picture, but the pieces in this bigger picture that I provide are very important because it makes like the foundation of further research and of like papers that are taken into consideration of other scientists that do research in the same area. So that's actually my part of the research community that I like. It's like the small stones that they build their theory on. That, yeah.
And would you recommend your career to the next generation?
Absolutely. I think the ocean is super important on very, very various aspects. And it's the big unknown. I mean, if you think how many people that have been in space and how many people have been in the deepest depth of the ocean, there are not many that have been there, and there's so much that we don't know. I mean, and it's also like the thing, like if you think like out of sight, out of mind. So there are still a lot of countries that put all the garbage in the rivers and into the ocean, and I think like it's gonna be even more important because if the population is increasing, you need more protein, and the only way you can get more protein, I mean, all the land is exploited as much as it can, and if you need more protein, you have to get it from the ocean, but then you have to you have to do it in a sustainable way. So I think it's super important that we get experts, marine experts, for all the different aspects in the future.
Mm-hmm. And what tips do you have for anyone who wants to become a marine biologist?
You have to be interested in biology in general, in all the aspects of living things. And then you have to figure out where to go based on the profile that interests you, like the university, and go there where the interest drives you. That's the most important thing.
Siv, a follow-up there. You had an interest in biology, and I'm curious, what other careers you had considered before zeroing in on this?
I didn't think about a specific career when I started in biology, because I wasn't sure if it even could be marine biology. But I always thought that it's like more important to be interested in something rather than like pinpointing out where you're gonna go in the end. At least it was for me, really to follow my interest, and then I think maybe it's like more the European way, that you don't always have like this major goal in mind, but go with your interests. Really, I mean, that's the most important thing.
That's very valuable.
Thank you very much. This is very interesting.
Thank you, and good luck with all the school tasks and choosing your way. Yeah.
Here's some takeaways from Siv Etter's interview. Siv started in medicine and found that she liked marine biology even better. Sometimes, even when you've been committed to something for a while, it's not always the best for you. If you have a chance to get a valuable role, take it. Even if you're pursuing something currently, you never know when you're going to get this chance again. If you're truly passionate about something, a PhD is great for you. I mean, yeah, it will be stressful, but you'll learn so much and make great people connections. Marine biologists do so much to keep the community safe. They're the ones who perform the tests that tell you if seafood is safe to eat or not. While researching is amazing, it might not work for some people. If the fast-paced world of research is different from your style, being a professor is a great way to keep learning and teaching.
Hey guys, hope you learned something new from this video. Please make sure to like, subscribe, and share with all your friends.